Hello everyone, now we are going to start the next chapter, that is Gyroscope. In the gyroscope, we will see the gyroscopic couples and angular accelerations, and we will see how the ship is going to be turned in the left hand directions or right hand directions, and what is called it as the nose, and what is tail, and what is stern, and what is bow. All terms related to the gyroscope we will see in this chapter. Basically, if I'm talking about the gate examinations, they will ask you to find out the gyroscopic couple generally. Okay, it may be 1 mark question, it may be 2 marks question. We will see all the possibilities here in this chapter. So in the gyroscope, first I'm going to tell you about the 3D space coordinate, because we are going to study the 3D. We will understand this first. Okay. So first topic is 3D space coordinate system. What is this? Coordinate system. So basically this is 3D space. Okay, we all know that. And this is X direction, this is Z direction, and this is Y direction. Let us consider that there is a plane. If I'm talking about the plane, so there may be three planes, because there are three axes are there. So there is a three plane. First plane I'm going to consider, this is the first plane. This plane is known as XY plane. Okay, and if you see the plane, this is YZ plane. If you want to draw the next plane, this is XZ plane. Okay, so this is XY plane, and this is YZ plane. This is YZ. Okay, this is YZ plane. These are the basic things you need to understand, and this is XZ plane. Okay, so next we will study about the angular velocity, because angular velocity is going to be used in the gyroscopic. This is the angular velocity. We all know that angular velocity is denoted as omega. What is basically angular velocity? If I'm talking about the magnitude, magnitude is nothing but the rate of change of angular displacement. So if I want to tell you about the magnitude of angular velocity, so basically it is equal to the rate of change of angular displacement. Angular displacement is denoted as theta. Rate of change of angular displacement. Rate of change of angular displacement. This is denoted by theta. This is the magnitude. And if I'm talking about the direction of the angular velocity, so this is predicted by the right hand thumb rule. Okay, this is predicted by right hand thumb rule. We all know how to use right hand thumb rule. Right hand thumb rule. Right hand thumb rule. So this is the magnitude and the direction of angular velocity. So how to use the right hand thumb rule? There is a procedure. Place the right hand in such a way such that thumb is perpendicular to the fingers. I'm going to tell you how to decide the direction of the angular velocity by right hand thumb rule. So the first is, place the right hand. You can write it as, place a right hand. Place the right hand in such a way. You can do practically in such a way that fingers are perpendicular to the thumb, or can say the thumb is perpendicular to the fingers, perpendicular to the fingers. So this is the first step. And what is the second step? Rotate the fingers in the sense of rotation. Rotate the fingers in the sense of rotation. In the sense of rotation. So we'll do the numerical questions. Then I will let you know how to decide the direction. So rotate the fingers in the sense of rotation. Then the direction of the thumb, whatever be the direction of the thumb, that will be the direction of angular velocity. Okay. So place a right hand in such a way that thumb is perpendicular to the fingers, and rotate the fingers in the sense of rotation. Okay. Then the direction of the thumb will then the direction of the thumb will decide then the direction of thumb will decide it will be direction of angular velocity. Angular velocity. So this is the process to find out the direction of the angular velocity. Okay. So the direction of omega is also known as axis of spin. I'm writing here the direction of omega, the direction of angular velocity is also known as axis of spin. Axis of spin. This is important. Okay. So here we have seen the magnitude. This is the rate of change of angular displacement, that is d theta by dt, and directions can be predicted by right hand thumb rule. And the procedure is that you have to place right hand in such a way that the thumb is perpendicular to the fingers, and rotate the fingers in the sense of rotation. Then the direction of the thumb will be the direction of angular velocity. And this direction of angular velocity is also known as the axis of spin. Let me give you the example so that it will be easy to understand what I'm going to tell you here. Here I am showing you the three examples. Okay. Now see here. This is a body. Let us consider a body or a disc which is going to be rotated. View. The important things, from which direction you are looking at the body. So this is the direction of view. This is the direction of view. You are looking the body from this direction. Okay. This is the direction of view. Okay. So when you see this body, it is going to be rotated. It is going to be rotated like that. And when you see from here, it would be clockwise. Yes or no? It would be clockwise direction. So this is x direction and this is z, and we know that this is y directions. This is y directions. This is y directions, and this is also y directions. So most important thing is that when you're looking at from here, the body is going to be seen in that directions. Okay. So it would be z o x. Okay. So axis of spin is what? Axis of spin is what? You have to find out the axis of the spin. Axis of the spin means the direction of angular velocity. Axis of the spin means the direction of angular velocity. And how we can find out the direction of angular velocity? Just by using the right hand thumb rule. You have to place the right hand. You have to place the right hand in such a way that the thumb is perpendicular to the fingers. Okay, in the direction OX, and you have to rotate. And you have to rotate the fingers in the sense of rotation. In the sense of rotation, whatever be the sense of this body, that means it is clockwise directions. So you have to rotate this. You have to rotate the fingers in the sense of rotations, that is clockwise, and then the direction of the thumb will. Then the direction of the thumb will decide the direction of angular velocity. So what would be the direction of angular velocity? This OX. This would be the direction of angular velocity. Okay, I hope you will understand. Okay, this would be OX would be the axis of spin. And what is the plane of spin? There will be a plane also. So plane of spin would be YZ. Okay, this is Y and this is Z. This would be the plane of spin. Okay, and if I'm talking about the next case, for example, the body is like that. Now you have to tell me the axis of the spin and the plane of the spin. Now, when you see the body from this again, from this side, and this is the direction of wave. Okay, you see this body that is going to be rotated here, and it is going to be rotated like that. It is going to be rotated like that. So when you looking the body from this direction, you can find out the axis of the spin as well as the plane of the spin. So what is the process for finding out the axis of the spin? This case we will consider in the next page. What would be the axis of the spin? Axis of the spin means the direction of angular velocity. Okay, so see here, you have to place the right hand in such a way that thumb is perpendicular to the fingers and rotate the fingers in the sense of rotation, that is anti-clockwise. When you're looking from this direction, the sense of rotation of the body is anti-clockwise. Okay, so you have to rotate your fingers in the anti-clockwise directions, and whatever be the thumb directions, that will be the direction of the angular velocity. So you will get the direction of angular velocity, that would be this. This would be the direction of angular velocity, and this is omega direction. Okay, because we are looking the body from this. Okay, so that means the axis of the spin is axis of spin would be again OX, because it is in x direction. Yes or no? X direction, it is x direction. And what would be the plane of the spin? Plane of spin would be YZ. Okay. In the next third case, again you have to consider a body which is going to be rotated in a different way. That means you have to change your view. Now, this time you have to change your view. This is the body. Okay. Now, this time I am looking at the body from this direction. Okay. This is the view direction. When you see the body which is going to be rotated in the direction, that is basically clockwise direction when you're looking at from here. Okay, so this is basically clockwise direction. Don't consider clockwise anti-clockwise. I'm just telling you clockwise anti-clockwise just for understanding purpose. Okay, you just have to find out the axis of the spin or the direction of the omega just by using right hand thumb rule. Okay, so just place your fingers, just place a right hand in such a way that the thumb is perpendicular to the fingers. Okay, and rotate the fingers in the sense of rotation, that is when you place your right hand here and you have to rotate your fingers in the sense of rotation. What is the sense of rotation? You can see here the sense of rotation is clockwise, so you have to rotate the fingers in the clockwise direction. So the axis of the spin or the direction of angular velocity would be decided by the direction of the thumb. So that is it. This would be the direction of the thumb, that is view direction, and this would be the direction of omega. Okay, so what would be the axis of the spin? Axis of spin would become OX, and the plane of spin would become. Similarly, you can calculate axis of spin for many possibilities. Okay, so that is YZ. I hope you will understand this angular velocity concept. Okay, there is no problem here. This concept will be used in the numerical questions. We will decide when we have to find out the directions of the rotation of the body or the aeroplane or the ship. Okay, so this is the basic concept. You need to understand how to decide the axis of the spin and the plane of spin. Okay, so I hope you will understand this angular velocity concept. Okay, so